The infinite vasts of the universe hold endless possibilities and secrets. And here's one of the intriguing questions: how life and we as humans would look like on other planets. Imagine a world where the laws of physics, the environment, and the conditions are vastly different from what we're used to. How would we adapt and evolve to survive in these strange new lands? Let's see. Mercury is the closest planet to the Sun and has a thin atmosphere. The temperatures there are extreme, with the day side reaching over 800 degrees Fahrenheit and the night side dropping to negative 290 degrees Fahrenheit. So, what can we do to survive these crazy temperatures and constant solar radiation? Maybe we can magically turn into metal. For example, titanium and platinum can perfectly tolerate high temperatures. But seriously though, there is an option. We could settle underground, where the temperatures aren't so frenzied. If we lived underground, we might evolve with large eyes to better capture light. We might also evolve thicker skin to protect ourselves from the intense radiation. Basically, we have two options: become metal or become moles. Let's move on to Venus. This planet is extremely hostile. First of all, Venus is known for its thick, more toxic than your ex type of atmosphere. The whole planet is covered with carbon dioxide, and its surface is absolutely dry, making it incredibly hot. The average temperature is around 847 degrees Fahrenheit, making it one of the hottest planets in our solar system. Also, don't forget about the crazy pressure. Standing on Venus would be like standing 3,000 feet underwater. Only particular hardy microbes from Earth could survive in such conditions. So, if you want to live on Venus, you might have to become a microbe. But unfortunately, since we're not microbes, we have to wear special gear and equipment to survive there. Maybe we'd have to develop a heat-resistant exoskeleton to protect ourselves, as well as get some new lungs that can filter out the toxic elements in the atmosphere. Let's talk about our favorite red sibling, Mars. The first noticeable change after a few hundred years would be your new skeleton. The gravity on Mars is much weaker than on Earth, so your muscles and bones would shrink. To make up for this difference, you'd have to eat more and probably start going to the gym. Also, you'd have to adapt to the low atmospheric pressure and colder temperatures. You need to retain heat, right? That means you'd need a thicker layer of body fat. Sorry folks, but on Mars, we might become fatter. Another reason to start working out. Another big change would occur in your skin. Your skin is like a big barrier that protects you from harmful things such as bacteria, UV light, looking totally creepy, and so on. So what would happen to it? Most likely, you would turn orange, due to the carotenoids. Carotenoids are a type of nutrient that you get from foods such as carrots, potatoes, tomatoes, and so on. They protect very well against ultraviolet radiation on Mars. They only have one downside. By eating a lot of pumpkins from the Martian farmers market, you'll gradually start to turn orange. But maybe it's not so bad. Maybe life on Jupiter would be easier. Yeah, no, it has no solid land. This planet is made up of hydrogen and helium and is referred to as a gas giant. You would simply float there, like in a huge cloud. And even if you managed to land and tried to walk, it would be like moving through a super thick fog. So how would we evolve there? Firstly, we might become much larger in size to withstand the immense pressures. Secondly, the temperature fluctuations on Jupiter are enormous. The surface is terrifyingly cold and the temperature rises significantly under the outer layers of the atmosphere. Thirdly, if you lived on Jupiter, there would be no verbal language. This gas giant absorbs radio waves, so even if you were speaking, no one would hear you. There would be no music either, so no parties. And what's the point then? Hey, maybe we could communicate with sign language, but that's not so simple either. Jupiter is full of wild winds and storm clouds, so it's unlikely you would be able to see anything. So even if we evolved there in some way, our lives would still not be easy. Before landing on Saturn, you would probably want to check out its iconic rings, but you wouldn't be able to do that because Saturn's rings consist of a bunch of ice particles flying in space, so it would be extremely hard to land. So let's go straight to Saturn itself. At first, it may seem that Saturn is not bad for us. Some layers of this gas giant have quite pleasant temperatures. If we dive deeper into Saturn, it gets surprisingly warm, up to 26 degrees Fahrenheit in its second layer. This is an average temperature in countries like Sweden and Canada. But unfortunately, this is only one such layer. The rest of the planet is incredibly cold, so in order to survive on Saturn, we'd have to do a lot of work. In addition to the cold, we'd have to deal with the planet's harsh environment, including its intense storms, strong winds, and radiation. To protect ourselves from these conditions, we'd need to evolve tough skin, again, find some insulation, and so on. Next planet is Uranus. Uranus has a very different environment from Earth, with much colder temperatures, a lack of a solid surface, and a much different atmosphere. It's like another Jupiter, but with blue vibes. It's not that bad though. There's even water on Uranus. The only problem is, the planet is full of ammonia, that nasty stuff we use for cleaning, so don't be surprised if you feel the gross smell. Also, it's incredibly cold out there, almost like a never-ending winter. So what would it be like to survive in such a dark and harsh environment? We'd need thicker skin, again, to cope with extreme temperatures. And again, we'd need larger eyes to see better in all this darkness. We might even have to develop a new hearing system, like that of dolphins. Wouldn't that be fun? Let's move on to Neptune. If human beings were to evolve on Neptune, they would need to adapt to its harsh conditions. Neptune, the 8th and farthest planet from our Sun, is another gas giant. The only difference is this planet may have a solid core. If we were to live on Neptune, we'd need to float or swim in its methane-rich atmosphere. We'd also need to develop gills or something like that in order to breathe. Basically, we'd turn into space reptiles or cosmic fishes. The gravity on Neptune is slightly stronger than Earth's, but strong winds make it difficult to stand in one place. To withstand the wind, we'd need to be much heavier. Once again, you need to eat a lot and pump up some muscles. Yeah, technically it's not a planet, but we still love it and can't forget it. A small, distant, and incredibly cold world. Pluto's even smaller than our moon, and because of that, there's almost no gravity there. It will be extremely difficult to stand on it. To avoid accidentally flying into outer space while playing football, we need to create a fake gravity machine. And if we don't want to feel dizzy, we need to evolve a brand new nervous system. But Pluto isn't all that bad. For example, there's liquid water under the surface, and even some icy mountains. Maybe it would be possible to survive there if we had some serious equipment, clothes, supplies, and… nah, too much hassle. Anyway, from the scorching heat of Mercury to the freezing temperatures of Neptune, each planet has a unique set of environmental challenges and opportunities for evolution. While we may never truly know what humans would look like on these other worlds, it's exciting to consider the endless possibilities. Never stop looking at the stars and asking these questions.
I hope you feel well rested, because I've got a tough task for you. Don't worry, it's fun. You're going to visit different planets of our solar system and try to run on each of them. Let's figure out where you can run the fastest and where you can barely walk. The fastest man on Earth, Usain Bolt, can run with an average speed of about 23 miles per hour, but his top speed is higher, up to 27 miles per hour. Sadly, we can't all be Usain Bolts. The average person runs at a speed of 6 to 8 miles per hour. But maybe there's a planet out there where you can beat the famous Jamaican sprinters' records. But first things first, what will affect your speed when you run on other planets? For one thing, gravity. Depending on how strong it is on the planet you visit, it'll influence your weight. And in most cases, the heavier you are, the more slowly you run. Plus, on all other planets in our solar system except Earth, you'll have to wear a bulky spacesuit. Without it, your chances of survival there are non-existent. And don't forget about extreme weather conditions on most planets. It's either freezing cold or boiling hot, or very, and I mean it, windy. Anyway, your amazing journey is about to begin. Buckle your seatbelt. The first planet on your itinerary is Mercury. As you sneak a peek at this world through the window of your spaceship, you notice that the planet looks eerily similar to the good old moon. But just a few moments later, you realize it's just an illusion. All over the surface of Mercury, you see craters left by space rocks. This may make your task of running on this planet way harder. This and your bulky spacesuit. Duh. But you wouldn't survive on Mercury without this protection. The temperatures on the planet are extreme. 800 degrees Fahrenheit during the day and negative 290 degrees Fahrenheit at night. But there's one thing that can work in your favor on this unfriendly planet. Let's say you weigh 155 pounds on Earth. Then on Mercury, you'd weigh around 58 pounds, which means that despite your bulky spacesuit, you can move way faster than you do on Earth. And maybe your speed will even reach 13 miles per hour if you try really hard. The next planet on your itinerary is Venus, also called the Morning Star. While coming closer, you see a world very different from the bluish planet you might have seen in books. Before landing, you have to get through a super dense atmosphere made up of carbon dioxide. And while your spacecraft is descending, you're watching thick clouds of sulfuric acid pass by. Venus is often called Earth's twin because these two planets are of similar size and density. No wonder that on Venus, you weigh almost as much as you do on Earth, 140 pounds. So your weight is a bit smaller here, but don't forget about your spacesuit. And still, because of almost the same conditions on the two planets, you'd be able to run a bit faster than on Earth at around 8.5 miles per hour. Your first impression of Mars is that it's freezing cold. The average temperature here is about negative 80 degrees Fahrenheit. Even from afar, the planet looks reddish. Once you make your first step on the Martian surface, you understand why. The ground's covered with rusty-colored dust. The same fine dust is floating in the air around you. Wherever you look, you see golden, brown, tan, and even greenish hues. They depend on the minerals that make up the soil. The size of the dust layer varies from area to area, but in most places, it's around 7 feet thick. That can make running much more difficult. On Mars, your weight would be much smaller than on Earth, a mere 58 pounds. This will help you achieve an impressive speed of 12 miles per hour. Aren't you a champ? What's that on the horizon? It looks like a tornado. Is it a dust storm? Then it's time to make a run for it. Dust storms sometimes cover the entire planet, and you can even see the largest ones from Earth. And now you're facing a problem. You see, Jupiter, as well as Saturn, is a gas giant. This means that the largest planet in the solar system, and Jupiter is so large it could swallow 1,300 Earths, doesn't have any solid surface. Well, you'll just have to imagine what your running workout would look like if you could run on Jupiter. This planet has an atmosphere that consists of hydrogen and helium gas. During your descent, you admire thick brown, yellow, red, and white clouds. They make the planet look colorful and beautifully striped. On Jupiter, you'd weigh 390 pounds. You'd have to break a sweat to simply walk there, wearing your clumsy spacesuit. If you could step on the planet's surface, that is. If you tried to run there, your best result would probably be a speed of 1 or 2 miles per hour. To make matters worse, it's extremely windy on Jupiter, with the wind speeds ranging from 200 to 400 miles per hour. Do you see those rings? That's Saturn, another gas giant with no solid surface. This planet's made up of mostly hydrogen and helium, and its temperature and density change the deeper you go. If you decided to leave your spacecraft and step on Saturn's surface, you'd just fall into the planet. But from above, it looks as if Saturn does have a surface. The seemingly solid yellowish-brown sphere is surrounded by several layers of clouds. The visible outer layer is made up of ammonia clouds. Under them, there are hydrosulfide clouds, and the innermost layer is made up of clouds of water. Even though Saturn is a gas giant, your weight wouldn't be very different here, around 165 pounds. That's because the planet's gravity is similar to that of Earth. But because of the conditions on the planet, and your bulky spacesuit, you'd run a bit more slowly there, at a speed of about 4 miles per hour. Before leaving, you admire Saturn's most famous feature, awesome gray, beige, and tan rings. These groups of tiny ringlets are made of chunks of rock and ice. You also spot several of the 53 moons of Saturn. Oh, that's Titan, an icy world bigger than our moon and even Mercury. It's the second largest moon in the solar system. The next planet on your way is a blue-green ball of ice and gas. That's ice giant Uranus. It has this beautiful hue because the light from the sun gets reflected off the planet's surface. Uranus isn't solid. Hit the brakes! If your spacecraft doesn't manage to stop in time, it'll fly through the upper atmosphere and sink into the icy liquid center of the planet. I doubt you'll be able to conduct your running experiment here. So let's just imagine what it'd look like. On Uranus, your weight would be around 138 pounds. And, against all odds, you could actually reach a good speed here, at least 8 miles per hour. If you didn't get caught in a hurricane, of course. Extreme storms occur on the planet in the summer, when Uranus is heated the most. Then, hurricanes can spread for more than 6,000 miles. The furthest planet from the Sun, Neptune, is 4 times the size of Earth, but 17 times as heavy. The blue surface you see when approaching Neptune is actually a layer of swirling gas and permanent clouds. The planet's mantle is made up of water, ammonia, and methane ices. It's the closest thing Neptune has to a surface. And still, there isn't solid ground for you to walk on. So, once again, try to use your imagination. On Neptune, you'd weigh a bit more than you do on Earth, 174 pounds, but your running speed would be just a bit lower than on Earth, around 5 miles per hour. That's the end of your active adventure. Which planet did you like running on the most?
Picture this. You've won a membership to a space gym. You get to travel around the solar system and work out. But gravity changes on different space bodies. So let's find out if you can get stronger elsewhere or if you should keep practicing on Earth. Your spaceship is approaching dwarf planet Pluto. It's getting chillier by the second. No wonder! The Sun is over 3.7 billion miles away. You must be glad you brought your thermal spacesuit along, right? To leave the spacecraft, Earthlings would need the help of a gravity machine, since gravity on Pluto is a mere 1/15th of that on Earth. Gravity is the force that pulls you toward the ground. The smaller the mass of a space body is, the weaker its gravity. So, on Pluto, you can't do any sports that involve running. If you did, you'd most likely fly away. You can try out elephant lifting, though. After all, you can't do it back on Earth. On Pluto, picking up an elephant weighing 2,000 pounds feels like lifting 120 pounds. The next stop is Neptune. It's over 30 times farther away from the Sun than Earth. The atmosphere there is dark and cold. You might get overwhelmed by the planet's gigantic size. It's called an ice giant for a reason. Maybe today you'll feel like doing some winter sports? To say Neptune exists in perpetual winter is an understatement. The average temperature on this planet is around minus 373 degrees Fahrenheit. But gravity here is only 10% stronger than that on Earth, so you don't feel much difference. This world doesn't have a solid surface, so you won't be able to leave the spacecraft. Is that an ice hockey rink I see? Grab your ice skates and your stick and get ready to outplay your fellow passengers. How about a quick pit stop on Uranus? This is another ice giant, and gravity here is 90% of that on Earth. You can do a few push-ups inside the spacecraft, as you won't be stepping outside. The slushy surface of the planet is made up of water, methane, and ammonia in its liquid form. There's no solid ground to walk on. But if you somehow found a way to go outside, you'd feel lighter than on Earth. If you weighed 100 pounds back home, it would be 90 pounds here. Can we call this a Uranian diet? When approaching Saturn, please mind its rings, which aren't actually rings. They consist of pieces of asteroids and meteors flying around the planet. Saturn's mass is so big that it attracts many other space bodies to its orbit. And right now, you're one of them. Time to get creative with your workout. You've scheduled a skydiving experience here. If you freefall in Saturn's atmosphere, you'll reach the speed of 30 miles per second. Don't forget to open your parachute. On second thought, though, you won't be able to touch the ground anyway. Saturn's surface is pure gas. Quick fun fact, once Saturn got in the way of the 10th planet forming in the solar system. The planet's debris, which partially makes up Saturn's rings now, could have blended into a planet, but it was pulled into Saturn's orbit instead. You're nearing Europa, one of Jupiter's moons. Gravity here is so weak you feel weightless. Let's say there's a rock climbing wall there. How about you give it a try? Usually, this sport requires a lot of physical strength, but here you'll only have to carry 13% of your weight. Your climb to the top will be easy peasy in these conditions. Entering Jupiter's atmosphere will feel like being inside a cloud. See that red spot in the bottom left corner? That's a storm twice the size of Earth that's been raging for hundreds of years. To have some fun here, why don't you do some jumping jacks? I'll count to 100. Ready, set, go. Gravity here is super strong. It's 2.5 times as powerful as gravity on Earth, so you'll probably get exhausted at the count of 30. Too bad. Uh-oh. Passengers aboard the spacecraft, fasten your seatbelts. You might experience some heavy turbulence. To travel from Jupiter to Mars, you'll have to move through an asteroid belt. Just in case you're worried your ship will bump into something, relax. There's a distance of 300,000 miles between asteroids. Let's stop at Ceres, the only dwarf planet in the asteroid belt. Gravity here will make you feel pretty strong. How about practicing some caber tossing? Cabers are heavy logs that can measure up to 20 feet long. The goal is to throw them as far as possible. Here, a 180-pound pole feels as if it weighs 5 pounds, which is, basically, the weight of a melon. Ready for the Ceres caper competition? Woohoo! Finally, Mars. Remember all those handstands you've always wanted to try? Well, here's the place to do them. Mars's gravity is about 2.5 times weaker than that on Earth, which means you'll probably be able to lift your own body weight without any difficulty. Since people keep trying to terraform Mars, opening a gym here doesn't sound like a bad idea, does it? Passengers and crew members, we're now beginning our descent to Phobos. It's one of Mars's moons. Gravity here is incredibly weak. If you've always dreamed of having superhuman strength, this is the place for you. You can work out here by, say, doing some artistic gymnastics. Start off with a cartwheel, then move on to tricks performed in the air. On Phobos, you can start doing triple back handsprings in no time. Ah, look, Earth is about to appear on the horizon. It sure looks majestic from here, but we won't stop there now. Instead, let's visit Earth's sister, Venus. It has almost the same mass as Earth, which means these planets have similar gravities. Now, Earthlings can't survive on Venus's surface because of the large amount of ammonia in its atmosphere. But let's imagine you could practice some outdoor sports there. Do you feel like trying bumper bubble soccer? That's when you dress yourself in a giant bubble ball vest and keep bumping into other players. People play this game on Earth. On Venus, with its slightly weaker gravity, it might be a little bit easier. But still, you have to consider you'll be wearing a 25-pound ball as a vest, kind of like a hamster back on Earth. Not to mention your outfit will restrict your arms and legs. It's a challenge, but it sounds fun to me. Moving on, if you land on the sunny side of Mercury, you'll experience scalding hot temperatures of 800 degrees Fahrenheit. If you're feeling tired after your space workout, a relaxing, steamy sauna will be just the thing. You'll feel like a brand new person by the time you arrive on the next planet. We'll fly as close to the Sun as we can so that you can have a taste of its gravity. The Sun's mass is huge. It's over 333,000 times the mass of Earth. And gravity here is extremely powerful. You'd have trouble lifting something as light as a bottle of water if you managed to step on the surface of the Sun. Too hot, you say? Well, I imagine it's a whole lot cooler if you come back at night. Haha, just kidding. On our way back home, we'll stop by the Moon. Our Earth's natural satellite. Walking on the surface of the Moon will feel like jumping. You'll be able to jump as far as 33 feet, so why not try some parkour? If you play basketball, scoring a point will be very difficult. But then you can jump higher than the hoop and do an epic slam dunk. And how about baseball? If you throw the ball upward, you'll probably never see it again. Finally, we land on Earth. Sorry to disappoint you, but you're not coming back with any superhuman strength. Even when you were lifting an elephant, gravity was helping you out a lot. It was a good trip, though. Don't you think so?
If you landed on Mercury, the first thing you'd notice would be how close it is to the Sun. It's actually the closest planet to the big ball of fire and the smallest, but it's not the hottest planet. Venus takes credit for that. It takes Earth 365 days to orbit the Sun, and it takes Mercury more than 3 months. Well, 88 days to be exact. The days are boiling hot, with a temperature reaching above 800 degrees Fahrenheit. But on the other side of the planet that the Sun doesn't reach, the temperatures drop to negative 300 degrees Fahrenheit. Mercury's atmosphere can't hold any heat when it's nighttime, just like a desert. Deserts have no atmosphere, which is why they have no moisture and no clouds or rain. If you manage to get from one end of the planet to the other and always stay in between the scorching heat and freezing cold, then you can survive. But oxygen isn't a friend to Mercury's atmosphere, so you just live for as long as you could hold your breath. Plus, there's a magnetic field that has solar winds from the Sun that create plasma tornadoes. Venus can heat up to almost 1,000 degrees, but gravity is really similar to that of Earth. You can go for walks by the mountains and even go jogging, but the temperature will instantly melt you, so maybe forget about those jogging sessions. The extreme pressure would also crush you like a can. It's like being half a mile underwater on Earth, so you'd only last a few seconds on Venus. The red planet is home to the highest mountain in the solar system, around 3 times taller than Mount Everest, and it's also a volcano. Despite being called the red planet, Mars is actually really cold. It needs a little less than 2 years to rotate around the Sun, or 687 days to be precise. And almost like Earth, it has 25 hours in a day. The atmosphere over there is very thin, but unbreathable. The planet has loads of dust storms that cover the entire planet, and polar caps that are covered with carbon dioxide. You won't freeze in your spot, but you'd need some thick clothing to keep warm. It's possible to last as long as you can hold your breath. On the bright side, though, you'd get to see some incredible views. The solar system's biggest planet is the mighty Jupiter. If Jupiter was the size of a basketball, then Earth would just be the size of a single grape compared to it. It only needs 10 hours to rotate around its axis, which is a lot shorter than Earth's. One of the best tourist attractions is the Great Red Spot, an area with a hurricane-like storm that's lasted more than 300 years. Oh, and the area is about twice the size of Earth. The largest planet in our solar system needs around 12 Earth years, or 4,307 days, to make a complete circle around the Sun. But Jupiter's gravity is a lot stronger than Earth's. Besides the lack of oxygen and winds that can keep you suspended in the air forever, the immense pressure would crush you. Visiting here won't last longer than a few seconds. Pluto is a former planet furthest from the Sun in our solar system, and is now considered to be a dwarf planet. And because it's that far, it's one of the coldest places ever, with temperatures reaching negative 400 degrees Fahrenheit. Definitely bring a jacket. Or 2. Methane ice covers the mountains that soar at over 10,000 feet. Pluto needs 248 years to orbit the Sun. It's technically still in rotation, waiting to celebrate New Year's, but it just needs 6 Earth days to complete a rotation around itself. And, surprise, surprise, the air is also unbreathable. Besides the methane floating around, nitrogen is also pretty common. The gravity is weak, so you'd have to hold your breath while floating in the air before freezing like an ice cube. Again, you'd only last a couple of seconds. The windiest planet in our solar system is Neptune. The core is similar to that of Earth. It has 14 moons surrounding it. A day is kinda short compared to Earth. You'd have only 17 hours in a single day. And similar to Pluto, it needs more than 150 years to spin around the Sun. Neptune is also known as the blue planet because of the absorption of the red light by methane in the hydrogen-helium atmosphere. So besides not breathing, the pressure can also crush you, just like on Jupiter. No one can last more than a few seconds there. The second biggest planet is none other than Saturn, with rings surrounding it. From far away, its rings look like one big chunk of rock spinning around, but in fact, it's made up of many layers of ice particles and rocks ranging in all sizes, from tiny pebbles to bus-sized objects. The rings are shaped in such a way because of the gravity around Saturn. A day on Saturn lasts only 11 hours. It's very windy in the upper atmosphere. Saturn also has plenty of moons like Jupiter. And, just like on Jupiter, you'd be crushed by extreme pressure deep in the planet before you can open your eyes. You wouldn't last longer than a few seconds here either. Titan is Saturn's largest moon and second largest moon in the solar system. It has the closest Earth-like conditions compared to any existing planet or moon, so living here should be a walk in the park. But the cold weather will freeze you. This moon is actually the only place in the whole solar system that has liquid rivers, oceans, and lakes. They're all covered with methane and ethane, and the atmosphere is very similar to that of Earth. It even rains here at certain times. Our moon isn't so friendly either. Because of the lack of oxygen, you can just last as long as you can hold your breath. The cosmic rays from the sun will also affect you, but skipping along the moon craters is actually quite fun. If you tried going to the sun, you'd vaporize in the blink of an eye. The temperatures can reach around 27 million degrees Fahrenheit, and that's just an estimated measurement near the core. There are still the outer layers you need to worry about that'll also leave you in atoms. Your best bet is to hit the brakes and take the nearest exit. Estimated time on the sun? Less than a second. Our little blue planet is the only place we can live in where an average human can reach 80 years old. We adapted to many weather conditions that aren't crazy, with the gravity just about right so we don't feel crushed. We can live anywhere from dry deserts to snowy ice peaks. It's the only place that has the perfect balance for us to survive. Scientists hope that one day we can live on planets other than our own. Mars is the closest place that can host us, considering we'd have to build a dome in order to live there. Elon Musk wants to use Tesla bots as the first non-human crew to land there and start building our future homes. The robots can acquire information about the planet and mimic the way humans walk and behave, so it'll let us see what we'll need to worry about. In all cases, humans will need to be suited up in order to come close to any planet. Our bodies aren't designed to face such conditions unless we evolve naturally to fit the environment. The tardigrade is the only animal on Earth that can live in the most extreme conditions, from the deepest oceans to the highest mountain peaks. They shot some of these microscopic critters into space and found out that they can live in the vacuum of space for up to 10 days and return without breaking a sweat. They're probably the only known creatures on Earth that can live the longest on any planet except the Sun. Scientists claim that if a large asteroid hits the Earth, then tardigrades can perfectly survive. But humans are simply not designed to live outside of Earth without the proper gear.
Get your closet ready. We're moving to Mercury. Your mission is to find out what you need to wear there to feel comfortable. So, Mercury is the closest planet to the Sun in our solar system. It's pretty hot here, about 800 degrees Fahrenheit, twice as much as your kitchen oven can produce. You need a heat-reflective suit like this. It looks like foil for duck roasting. The shiny, almost mirror-like surface reflects the heat rays and keeps everything inside from getting baked. That's you. This suit is designed to get to the hearts of volcanoes on Earth and can withstand up to 1,470 degrees Fahrenheit. That's twice as much as at the equator of Mercury. Oh, and bring an oxygen tank. Otherwise, you won't be able to breathe there. And you need to strap some heavy dumbbells to your legs. Mercury is smaller than Earth, and gravity is almost 3 times weaker here. So you have to increase your weight almost 3 times to feel comfortable. It gets extremely cold there at night, so you need to stuff your thermal suit with insulation. But even that won't save you from the cold. It's 3 times colder than at the North Pole. Plus, Mercury's atmosphere doesn't protect you from solar radiation as well as Earth's. So, you need to wear thick lead plates under your suit for protection. But the best thing to do is just evacuate from this planet. The next one is Venus. Although it's called Earth's twin sister, the scenery here looks frightening. A hot desert with volcanoes and clouds so dense that you can barely see the sun. These clouds contribute to the greenhouse effect. So, Venus is the hottest planet in the solar system, 890 degrees Fahrenheit. But the usual heat-reflective suit won't help you this time. The atmospheric pressure here is 92 times higher than on the surface of the Earth. That's like diving 3,200 feet underwater. So the air on Venus will just crush you. To survive, you need an airtight suit made of titanium or other sturdy materials. On Earth, we use an atmospheric diving suit like this to withstand the intense pressure underwater. It's like a mini submarine in the shape of a human body, and it's already equipped with an oxygen tank. Yes, the air on Venus is not only unbreathable, it's also toxic. The next planet is Earth. Just look out the window and decide for yourself what to wear today, okay? Let's go to Earth's satellite, the Moon. A few people have been here already, and they were wearing pretty big spacesuits. The main thing is to bring an oxygen tank. It's contained in a backpack along with the life support system. Even though it's cold, there's no atmosphere. It's almost a vacuum, and there's no air particles to take heat from your body, so you won't freeze instantly. Your suit itself should be airtight and keep the atmospheric pressure inside. The lower the pressure, the lower the temperature the fluid can boil over. In space, fluids from your body can evaporate in seconds. You don't want that, so you should wear a spacesuit. It'll also save you from dangerous solar radiation. The Moon is defenseless against it. And the gravity here is 6 times weaker than on Earth. So you can jump 6 times higher and lift 6 times more weight. It makes sense to take a little weight with you, so you don't feel as clumsy as the first astronauts. Next stop, Mars. In summer, you could walk around here in shorts and a t-shirt. The highest recorded temperature here is about 95 degrees Fahrenheit. In colder times, you'd have to wear a sweater and a warm jacket here, maybe even 2. The average temperature here is slightly colder than the coldest point on Earth. But the atmospheric pressure here is frustrating. It's 170 times less than we're used to. Take the altitude at which commercial airplanes fly on Earth. Multiply it by 3. The conditions there are very similar to those on Mars. It's cold and there's no oxygen to breathe. Without a spacesuit, you'd last 2 minutes at most on Mars. So you need an airtight spacesuit on you all the time on the surface of Mars. NASA scientists are preparing a new generation of spacesuits that will allow astronauts to climb, crawl, and bend without difficulty. You'd feel like a real athlete on the surface of Mars. The gravity there is 3 times weaker than on Earth, so you could easily lift an animal the size of a tiger there. Don't forget to put a spacesuit on it, of course. Now let's fly through the asteroid belt further into space and arrive at Jupiter. It's the largest planet in our solar system, and it's a gas giant. That means there's no solid surface, so you can't even stand there. Although, hypothetically, you could jump into Jupiter. Then you'd keep falling all the way to the planet's core. Suppose you're standing on a platform just above the surface of the planet. The first thing you feel is the force of gravity. It's 2.5 times stronger here. You feel it pulling you down, and you can barely even jump up. So it would be nice to equip your spacesuit with an exoskeleton to support your body and help you move. Plus, it's incredibly cold. You'll feel the cold at about negative 229 degrees Fahrenheit on the surface of the clouds of the gas giant. And what makes things worse is the constant wind. It can reach speeds of up to 900 miles per hour, almost twice as fast as the speed of commercial airplanes on Earth. That kind of cold wind will instantly draw heat away from your body, so your spacesuit must be really thick and warm. But the pressure at the top of these clouds is almost the same as on Earth. Technically, you could even take off your helmet here if it weren't for the lack of oxygen and severe cold. Maybe Saturn promises better conditions. Another gas giant. The gravitational force here is almost the same as on Earth, so nothing will constrain your movements, except for a massive spacesuit. It's even colder here than on Jupiter, and the pressure here is about the same as about 15 feet underwater on Earth. So, the spacesuit not only lets you breathe and stay warm, but keeps your eardrums intact. Hey, hold on tight! You just almost got blown away by a gust of wind over 1,100 miles per hour. That's not unusual on Saturn. That kind of wind on Earth could get you from one coast of the United States to another in just 2.5 hours. The only option to warm up here is to jump down to the center of the planet. The closer you get to the core, the warmer it gets. But the pressure rises at a tremendous rate. In just a few seconds of freefall, even the toughest titanium suit will be crushed. Let's finally step onto a solid surface, Titan, Saturn's moon. It's 1.5 times the size of our moon and 80% heavier. And its surface is mostly composed of water, ice, and rock. The pressure here is a little bit higher than on Earth. You wouldn't feel any discomfort if it weren't extremely cold. Titan is 9.5 times further from the Sun than Earth, so our star can barely warm this moon. The air here is mostly nitrogen, just like on Earth. But oxygen is completely absent here, so it's impossible to breathe without a spacesuit. There may be a huge ocean beneath Titan's surface. Saturn's gravity heats up this moon's core enough to make the ice melt. Plus, it must be extremely salty, which means it can remain liquid even at very low temperatures. The next two planets are Uranus and Neptune. So Uranus holds the record for the coldest planet in our solar system. The temperature here is about negative 224 degrees Celsius, so bring the warmest spacesuit you have. They say if you jump to the center of Uranus, at one point the pressure becomes so high that it turns hydrogen into a crust of ice. And if you get even lower, you can see the rocky core. Neptune, in turn, holds the record for the strongest winds in the solar system. It's an ice giant, just like Uranus. So the dress code here is the usual: a super warm spacesuit, a tank of oxygen, and a heating system. So far, we don't have the kind of spacesuit that would help you survive on any of the gas giants. But if you get to the core of Neptune, it gets too hot. Its temperature is almost the same as on the surface of the Sun.
Hey, listen up. Do you want to lose weight fast or gain more mass in just a few seconds? Forget all about diets and sports. We have an out-of-this-world way to do it: space travel. And now I'm taking you to the heart of our solar system, to the Sun. Hold on and bring your shades. There's no solid surface here, just hot liquid plasma. So take your heat-reflective suit and stay on the platform just above the boiling surface of the star. On Earth, you weigh 135 pounds. But here, on the Sun, your weight is about 3,600 pounds. That's like a small sedan or a hippo. Hey, just saying. It has to do with gravity. The bigger and denser a space object is, the stronger its gravitational pull, and the heavier your body feels. The Sun is 99% of the mass of the entire solar system. But although the star is 333,000 times as heavy as Earth, it's also much bigger. That's why gravity is only 27 times stronger on its surface. You can't stand up straight here, you get pulled down by gravity. And if on Earth you could lift 135 pounds of your own weight, here you can only lift a small pumpkin. Happy Halloween! Moving on, Mercury, the closest planet to the Sun, is very hot, about twice as hot as the maximum temperature in your kitchen oven. You jump down onto the rocky surface of Mercury and step on the scales. They show only 51 pounds compared to your real weight of 135 pounds. Mercury is almost 17 times smaller than Earth, but its core and crust are very dense. So the gravity here is only 2.5 times weaker than that on our home planet. It means you can jump 2.5 times higher here, and you feel much stronger. You can lift a big gorilla, but don't forget to make it wear a spacesuit with an oxygen supply. When night falls on Mercury, the planet cools down incredibly quickly. The temperature drops to 3 times as low as at the North Pole. So let's get out of here before you freeze completely stiff. The next planet is Venus. Oh, there's a nasty smell. It's the sulfur dioxide in the air. It would also smell like this near a volcano on Earth. You get on the scales and 122 pounds, almost as much as on Earth. No wonder Venus and Earth are called twin sisters. This planet has almost the same size as ours and only 20% lighter, so it has almost the same gravity. But you couldn't live here because Venus is the hottest planet in our solar system, and the atmospheric pressure on its surface is 92 times as high as what we have on Earth. You'd only feel the same pressure if you dived 3,000 feet underwater on our home planet. Without special equipment, you'd be crushed at such a depth. Your spacesuit is made of titanium to withstand this kind of pressure, just like an atmospheric suit for deep-sea diving. And it weighs about 830 pounds. It's like carrying the weight of a motorcycle. That's why you feel weaker here than you do on Earth. But moving on to our home planet, or more specifically to its satellite, the Moon. Several astronauts have been here before. You might have seen videos of how awkwardly they moved around, sometimes even falling. That's because gravity on the Moon is 6 times weaker than on Earth. your solid 135 pounds of weight turns into 22. So now, you weigh like a plastic shopping cart. On the bright side, you can now lift 6 times that weight. You can flip a car or lift a pony. You can probably even lift the lunar rover that's still standing here left by the last moon mission. One of the astronauts, Alan Shepard, hit several golf balls here, and one ball weighs less than a half an ounce on the moon. Hey, maybe you can use all that power to clean up the stuff people left here. That's about 250 tons, including rovers, broken space probes, lunar module sections, golf balls, and the like. Nah, let's do the cleanup later. Now we're going to Mars. Hey, you're the first human on the surface of the red planet. And the first thing you do is weigh yourself, of course. 50 pounds, almost 3 times less than on Earth. It's even less than the weight of a capybara, a big rodent from South America. That's because Mars is 50% as light and 10 times as small as our home planet. And since gravity is weaker here, you become 3 times stronger. You could lift 2 of your friends. But this kind of gravity is actually a problem for people. We're planning to colonize Mars, but our muscles are used to the constant gravity of Earth. They won't work at their full capacity on the red planet. This will cause health problems for the astronauts, so they'll need to exercise all the time or tie weights on themselves to become heavier. They'll have to carry at least 10, 20-pound dumbbells to get close to their real weight and keep their muscles toned. Now, a quick trip to Jupiter. This is a gas giant. Hey, again with a gas. And it doesn't have a solid surface. All you see are dense clouds, so it's probably best to stay on the platform. Jupiter is 317 times as heavy as Earth, so the gravity here is much stronger. Your scales show 340 pounds. That's like the weight of a big wild boar on Earth. Now, you can barely stand on your feet in your spacesuit. You feel very weak. The maximum weight you can lift here is 60 pounds. That's as much as a husky dog weighs. Let's take a look at Jupiter's moon, Europa. You stand on the scales and see 18. Yup, gravity is so weak here that you weigh like a garden gnome. At the same time, you can easily lift 1,000 pounds. That's like a horse or a grand piano. With that kind of strength on Earth, you could flip a school bus or lift a small car over your head, if you wanted to. Moving on, Saturn, another gas giant. Hold on tight, winds here can reach 1,100 miles per hour. Such a gust of wind could carry you across the United States from one coast to another in just 2 hours. Hurry up and get on the scales, 144 pounds. It's a little more than you weigh on Earth. That's why you feel a little weaker, like after a good workout at the gym. Saturn's moon, Titan. You might want to stick around a bit longer because here you feel like a real weightlifter. You can lift 7 grown-ups in your arms, or a great white shark. Just be careful with those teeth. And your own weight here is about 17 pounds, like a domestic cat, maybe a fat tabby. Uranus is the coldest planet in our solar system. It's 10 times as cold there as in a freezer. The scales show 120 pounds. You can lift a truck wheel here. The last planet in our solar system, Neptune. It's 17 times as heavy as Earth and 4 times its size. And the strongest winds ever recorded blow here. The number on the scales is 150 pounds. Yep, you've gained a little weight. But the same would happen if you took a dumbbell in your hands on Earth. Now, how about moving to more unique space objects? For example, a neutron star. This is one of the heaviest and densest objects in the universe. A neutron star has the weight of the Sun, but it's so small that it would fit in Manhattan. But this space object has a solid surface, so you can land your spaceship here. The neutron star's weight and density makes gravity incredibly strong here. Your 135 pounds on Earth turn into 190 plus 11 zeros pounds here. You'd be flattened like a pancake on a neutron star. You wouldn't even be able to pick up a match here. A regular sewing needle would weigh 140,000 tons. That's like 2,000 Boeing 737s. Next in line is a black hole. Well, we don't even have a number to describe your weight here. Black holes are the densest and heaviest objects in the universe. They lie at the centers of galaxies and can weigh millions and billions of times more than the Sun. They're so heavy that they warp space-time. Once you're in a black hole's gravitational field, you can never get out of there. And the gravitational pull increases with every inch you get closer to the center of the black hole. If you were falling into a black hole and extended your arm forward, The force affecting your fingers would be much stronger than that pulling on your elbow, and your hand would stretch like spaghetti. Your weight is infinite here, and your strength is infinitely small. Don't even hope to lift a single atom or photon of light here. Yeah, that's enough. Let's go home.
You accepted an offer to participate in an experimental program that'll take you and your colleagues to different planets in the solar system to see how humans can live there. As a volunteer, you dedicated your entire life to this study. You're 25 years old, and your destination is Mercury. Your colleague, Ryan, is 45. He'll be based on Pluto. Nora, 18, will go to Jupiter. Jeff, 65, will go to Mars. And Vivian, who's also 25, will head to Neptune. Each of you will have a unique chemical compound to boost your lifespan before reuniting. You're all in the launch pad and ready for takeoff. Each of you sits in the cockpit of your spaceship, and it blasts off right to your planets. Even though Mercury is the closest planet to the Sun, it's not the hottest. That honor goes to Venus. But it is the fastest planet to orbit the Sun. On Earth, a year is composed of 365 days. But on Mercury, you'll only have to wait about 3 months to celebrate the new year. 88 days to be exact. Your team's concept of time will change drastically. A part of Einstein's theory of relativity is that time can be affected by acceleration and doesn't flow steadily. It moves slowly for objects that are in motion, rather than a stationary observer. It's also affected by the gravitational pull. The closer you are to a large mass with strong gravity, the slower time will be. People can't perceive this phenomenon. Scientists estimated that the difference is around 90 billionths of a second over 79 years. But at different planets with different gravitational mass, the differences might be visible. Astronaut Scott Kelly went to space, while his twin brother, who is 6 seconds older than him, remained on Earth. When Scott returned, the gap extended to 6 seconds and 5 milliseconds. You arrive in your dormitory and unpack your stuff. Outside, you see the wasteland, and the temperature is above 800 degrees Fahrenheit. But at night, the temperature drops to a whopping negative 300 degrees Fahrenheit. That's because Mercury doesn't have an atmosphere to trap any heat to keep the planet warm like a desert. The magnetic field has solar winds from the sun that create strong tornadoes with hot plasma. After settling in and placing all your fabulous sci-fi books on the shelf, the ground shakes and knocks down some stuff. Mercury's surface has active tectonic plates that cause earthquakes. It's just something you'll have to get used to. You're able to have a video call with the rest of your colleagues for a quick catch-up. Ryan is on Pluto, billions of miles away from you, and has the worst reception. Pluto is considered to be a dwarf planet and one of the coldest places in our solar system, with temperatures reaching negative 400 degrees Fahrenheit, so Ryan doesn't really leave the dorm. He takes his webcam and shows you and everyone else what's outside his window. There are mountains higher than 10,000 feet covered with methane ice. Pluto needs 248 years to orbit the Sun, which means it'll take Ryan the most time to celebrate New Year's. No human can last for such a time on Earth, but the chemical enhancements make it possible. On this day, Ryan will have to wait 90,520 Earth days for New Year's. With gravity, he might age much slower than anyone on Earth. After he shows everyone around, the youngest one in the experiment, Nora, vlogs her new setup in the solar system's biggest planet, Jupiter. Jupiter is so giant that more than 1,300 Earths could fit inside it. That's like 1,300 grapes versus the size of a basketball. And even though it's that big, the planet completes a rotation around its axis in just 10 hours, so a day is considerably shorter here than on Earth. She shows you around her dorm, which resembles a fun playground filled with entertainment. The whole complex is sturdy enough to withstand the extreme winds that can reach more than 335 miles per hour. The people in charge of the experiment were smart enough not to place the complex in the Great Red Spot, an area with a hurricane-like storm that has lasted more than 300 years. And this spot is twice the size of Earth. Jupiter needs around 12 Earth years to make a complete orbit around the Sun, which is 4,307 days to be exact. This would mean that Nora would have to wait 24 Earth years to be 20 years old technically. But Jupiter's gravity is a lot stronger than on Earth's, which means she might age twice as fast. After showing everyone around, Jeff, the oldest one, begins giving everyone a tour of his place on Mars. It's called the Red Planet because it's rich in iron minerals, which might rust. His bunker is classy and feels the most luxurious over all of the others, and it has the best view as well. You get to see the highest mountain in the whole solar system, about 3 times higher than Mount Everest. Olympus Mons is also a volcano, as if being the tallest mountain wasn't already something extraordinary. Mars needs 687 days to orbit the Sun, which is a little less than 2 Earth years. It may not be the quickest in the solar system, but it's not as extreme as Pluto. Mars also has weaker gravitational force than Earth, but with 25 hours a day, he may not feel the time difference compared to everyone else. Vivian jumps in late in the call to show around her place on Neptune. She used to live near some hills and mountainsides, so the windiest planet in our solar system isn't that challenging for her. It has a rocky core like Earth and an uninhabitable atmosphere. Neptune is blue because of the absorption of red light by methane in the hydrogen-helium atmosphere. She shows everyone a view from her panoramic window, and you can see all 14 of Neptune's moons and some cloud formations. A whole day on this planet is just 16 hours. Vivian would have to wait 164 Earth years for Neptune to orbit around the Sun, which is 59,860 days on Earth, beyond any ordinary lifespan for humans on Earth, but a giant tortoise could be okay with that. But with everyone using a special chemical compound, the experiment could be conclusive. Gravity is also strong on Neptune compared to Earth, so she might age just as fast as Nora on Jupiter. After the video call, you take a tour around the complex and find out that other people stay with you in different bunkers, and the same goes for your colleagues on the other planets. 1,000 years later. You've forgotten what Earth looks like. You've forgotten what the atmosphere felt like, and even the wind brushing against your skin. But you've made your place pretty cozy, with so much plant life and cloned animals from Earth in the biochambers. You completely forgot about the mission at this point, and suddenly got a notification about a video call to update everyone about your progress. You set it up and wait for everyone to log in. After about a minute, no one responds. You haven't heard from them since the last video call 1,000 years ago. But then, one by one, everyone joins the video conference. The chemicals in everyone's body, which is enough to extend your lifespan, doesn't affect your body physically. It doesn't make you age at the same rate as on Earth, but it slows it down quite well over 1,000 years. Not everyone looks the same. Ryan was 45 years old on Earth, but he's only aged 4 years with Pluto orbiting the Sun 4 times in 1,000 years. He's now 49 years old, but if he were on Earth, he'd be 1,045 years old. But since he was on Pluto with weak gravity, he didn't physically change as drastic as predicted. Nora was 18 when she went to Jupiter and is still the bubbly girl she was 1,000 years ago. It takes 12 years for the planet to orbit the Sun, which means she's now technically 30 years old on Jupiter. But with Jupiter's strong gravity, she now looks 60 years old. Jeff landed on Mars when he was 65 years old, and if it takes 687 days for a complete orbit around the Sun, then that would make him 596 years old at the moment. Instead of looking extremely old, the weak gravity on the red planet made him age slower relative to the time spent. He looks to be around 80 years old. After landing on Neptune, Vivian, who was your age, is now only 31 years old on the blue planet. It takes 164 years for it to make a full rotation, making her quite old. And with Neptune's gravity just as strong as Jupiter's, she jumped in age and looks like she's in her 70s. You reveal that you're 4,147 years old on Mercury. Since it only takes 88 days for the planet to revolve around the Sun, you're now technically the most senior amongst them. But Mercury's weak gravity makes you look like you're in your 40s.